Welcome to Energy Talks, a regular podcast series with expert discussions on topics related to power system testing, data management, and cybersecurity in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. Having access to electrical power does not feel special to most of us. For example, if you switch on the light, you expect the room to be lit up. If you plug in your hairdryer, you expect it to work. Blackouts seem to only happen in movies. We don't think about them until we have to deal with them. However, we should be aware that the probability of blackouts is actually increasing. The reasons are complex, but utilities and energy suppliers are aware of them. They not only do everything to prevent a blackout from happening, but they also practice for the worst-case scenario and how to restore the power grid efficiently. OMICRON recently participated in one of these grid restoration practice exercises with transmission system operators Amprion and Transnet BV and a big pump storage plant operator, Schluchseewerke AG, all located in Germany. It was the largest grid restoration practice exercise in Germany to date, requiring many preparation efforts and a large amount of testing equipment. In this episode of Energy Talks, we speak with OMICRON application engineer Lukas Dieterich. He and his team were involved in this extensive practice exercise, and he will give us an idea of what it was like to set up and perform all the necessary measurements with a total of 34 Daneo 400 testing devices from OMICRON. Hello, Lukas. Welcome to this episode of Energy Talks.
Good morning, Scott. Thanks for having me.
Well, it's great to have you here. Lukas, before we discuss the blackout practice exercise you and your team participated in, let's give our audience a little background. First of all, can you tell us why the probability of a blackout is increasing?
Actually, Scott, the reasons are complex. On the one hand, we see that the energy supply system is undergoing major changes. For example, we have the transformation from centralized large generation to more distributed energy resources. Another example could be that we are changing from fossil fuel to more electric energy. We see this at electric cars or electric heat pumps that are more increasingly common now. And then, on the other hand, there are also external factors. For example, we see hacker attacks or armed conflicts up to war.
Okay. So how are utilities dealing with the situation? Are there any countermeasures being implemented?
Yeah, first of all, to begin with, we have a very reliable system in Europe, the energy supply system. It's not only very reliable, but also available all the time. So it's really a stable system. And this is not a coincidence, but the grid operators and the utilities, but also all other involved actors, let's say, put really the highest efforts to guarantee this stable power supply. But, of course, there are also really measures to prevent blackouts from happening. First of all, preventive measures, of course. This can be building up the system in a redundant way, but also, and this is what we especially see at our customers, the increasing cybersecurity awareness. These are, let's say, preventive measures. But then, of course, there are also measures really directly addressing a blackout event or situation. For instance, this is that the system operators do have a grid restoration concept. So let's call it a plan, what they do in case of a blackout. And of course, they are also doing trainings to deal with this kind of events, either in a simulator or that's, from my perspective, even better, in a real experiment. And this kind of real experiment is exactly what Amprion and Transnet BV, which are two of the four big German, or not big, but only four German transmission system operators, together with the Schluchseewerke AG, which is a big pump storage plant operator in Germany.
Okay, so what happens in the event of a blackout?
Well, the exact processes are complex, and you would have really to talk to a grid operator to get a satisfactory answer, I would say. But I try my best. In general, so-called black start capable power plants are used to re-establish the voltage in a part of the grid. And we could call these re-established parts, let's say islands, voltage islands. And starting from these voltage islands, the complete grid will be restored step by step.
Okay. So, Lukas, can you tell us what is meant by black start capability?
Yeah, of course. Let me put it this way. The most conventional large-scale power plants that we have in mind, for example, coal or nuclear power plants, are not black start capable. And this means during the startup process, when they are switched off and started again, they need an external energy supply. So by definition, in a black start event, they cannot be switched on. And on the other hand, we have the black start capable plants. These are able to restart autonomously without an external power supply. Plants like this may be hydroelectric power plants or special gas turbines, but in particular, it's appropriate pumped storage plants, such how they are used by the Schluchseewerke AG.
How often do grid operators need to verify their grid restoration plans?
Actually, the European Network of Transmission System Operators for Electricity, or let's call it short ENTSO-E, they agreed in a special network code, the Network Code on Emergency and Restoration, to verify these restoration plans at least every 5 years.
So, coming back to your involvement with this topic, how does testing play a role in the verification process?
Yeah, I think I have to extend this answer a little bit. I mean, it's clear that the blackout event, and especially the following grid restoration, means a very rare occasion, but at the same time, it puts the assets of the power plant, of the grid, under extreme pressure, or in a, let's say, extreme operating conditions, which is not common in the normal grid operation. And that's why the operators need to test and investigate the behavior of these assets in exactly these extreme operating conditions. So this they can only do, of course, in a test or in a blackout event, but as mentioned, these are very rare. So now, by doing the test and measuring the major nodes and assets in the trial grid extensively, they can be sure that they don't miss any important event. And in the end, they can take the measurement results to really verify that the equipment can perform as expected. But in other words, a reliable verification is just simply not possible without a real test, I would say.
So is the general public without power during these grid restoration plan verifications?
I can definitely give you the answer, no, they are not. The good thing is that for this kind of tests, part of the grid will be separated from the public power supply, and the tests are just performed in this separated part of the grid, let's say. Additionally, even to reduce the stress on the rest of the power system even more, the tests are typically done on the weekends or even occurring at night sometimes when the overall load situation is more relaxed.
So, Lukas, let us discuss the blackout practice exercise in which you and your team helped utility companies in Germany restore power in a blackout scenario. What role did OMICRON play in this exercise?
Well, Scott, our customers not always have the necessary experience for complex measurements like this, but especially, like it was here the case, they don't have the number of measuring devices which are required in this huge setup. Therefore, we are, of course, proud to support Amprion, Transnet BW, and the Schluchseewerke to realize ambitious project like this. We are speaking here about really an unprecedented number of measurement devices. We are speaking of 34 Daneo 400s, and of course, also the additional accessories, including CM GPS, current clamps, shunts, switches, not even speaking of that everything of these devices must be calibrated and tested beforehand. So for us, it really became obvious that this was indeed the largest project of this type in Germany so far, when we had to ensure that all the equipment was present. Alone several hundred cables we had to count and pack.
So what are the requirements for a project like this regarding the measurement system used? In this case, the Daneo 400.
Yeah, good that you mention it. The demands of the measurement system cannot be underestimated, as there is a real bunch of requirements. First of all, the system must enable the spatially distributed measurement over many kilometers, in this case even more than 100 kilometers, which the different stations were apart from each other. Then, of course, any number of measuring points, in this case devices, Daneo devices, must be included in the test setup and must record in a time synchronized way. Then we can continue with that live monitoring must be possible. So the live monitoring of the measurements must be displayed and be possible from one central operating computer, and also all of the devices must be controllable from this central computer. And then additionally, a requirement is not only to measure power system values like we expect voltage and current, of course, but also specific sensor values from the assets in the power plant, like rotational speed of a generator or the pressure in a turbine and so on. All these measurements then must be provided with a high sampling rate, so we can really be sure that we don't miss any kind of events, especially really fast or transient events even can be recorded with this high sampling rate. And speaking of the recordings are stored locally on the device itself or on a connected mass storage. This is also possible. And then afterwards, they can be analyzed in the Daneo control software in a safe and sound environment of the office, of course. All these characteristics together, we can really say and proudly say that these make the Daneo 400 really to a unique solution on the market, which is unmet and really designed or even, let's say, tailored for such applications.
Interesting. So what were the biggest challenges you faced during the project?
Yeah, actually, in a complex and interdisciplinary project like this, of course, one of the main challenges, not only on our side, but also on the customer side, is, of course, the organization and coordination. You have to understand there are so many different parties involved from different departments, and all of them are experts in a different field. It really is a huge challenge to bring them all on one table. On our side, the main difficulties were especially the coordination, the preparation, and the configuration of the equipment. As it was an ambitious and huge test setup like this in this project, we even decided to install and configure everything in advance and perform a pre-test to be really sure that everything is ready for the real grid restoration tests, as they are really, it's a big challenge even for the grid operators to have this test grid ready. It's also a big cost for them, financial speaking, and so they really want to rely on that the measurement is working as it should.
Very good. So there was a lot of time put into the preparation. How long did the actual test take itself?
Yeah, let's say it's one test containing different test steps, but it's basically we had this pre-test, which was a half day, and the test itself, which was about 1 day out 8 hours. But as you were speaking of the preparation time, overall the preparation time took about 4 years even.
So this is something the utilities were putting a plan or a concept together for, and that's what takes the time, wouldn't you say?
Yeah, you're of course right, and I don't have all the details in their procedure, but of course there are also legal hurdles, let's say. They have to clarify with insurance and so on and so forth. So there's a lot of bureaucracy, let's say.
Okay. And would you say that your pre-preparation, your pre-test, actually saved you time during the actual test?
I would say it's more about guaranteeing that everything is up and running correctly, but it doesn't really save time. Or you could say, of course, we excluded some, let's say, ratio errors or settings of the measurement with this pre-test. But in general, it's more to guarantee that everything is working as expected.
Okay. So can you give our audience an overview of what happens during a grid restoration practice exercise like the one you participated in with your team?
Well, you're getting really into a pretty technical discussion right now, but yeah, I try my best. Of course, the procedure is individual in every project, and also to a certain extent confidential, we must add here. Mm-hmm. But in general, we can put it this way. First of all, before the test really starts, the preconditions must be established. And this means the trial grid, as mentioned, must be separated from the rest of the power supply system. All of the power plants in the trial grid must be shut down. And therefore, we established, or the grid operator establishes, a trial grid without voltage, or let's say a switched off trial grid. And then now the real grid restoration test itself can follow. And typically, it includes the following steps, more or less. First of all, the power plants involved need to prove their black start capability. So this is a central point, let's say. Then we already heard it, originating from these power plants, the trial grid will be energized. And after everything is so far up and running, the grid operator wants to see or wants to try out different load and generation scenarios which are played through. During all these steps, of course, the behavior of the involved systems, we already heard that it's extreme conditions for most of the assets. So during all these steps, the behavior of these involved systems is under the most careful observation then.
Okay. And so if something was found where the performance was not as good as expected, then you know that something needs to happen there. Is that correct?
Yeah, I mean, I cannot say that something was not as expected, Everything is working, but of course, some points can be improved in the future. This could be the setting of a controller or the exact procedure when to switch which asset and so on. Yeah, this can happen in this kind of tests, and then either you take it as a learning for later on, or you even adapt the test procedure during the day.
Okay, very good. So what were the results of the blackout practice exercise?
Yeah, also here, due to confidentiality reasons, I cannot really go into the details, but to answer it in a general way, first of all, the test was successful. So everything could be done and the goals of the customer could be reached. And for them, as well as for us, there were some real valuable learnings. In principle, what they can take away from it is normally to further improve the grid restoration plans, train their employees so they get more routine in this kind of doing, let's say, re-establishing the voltage. And in the end, the entire process can be optimized.
Okay. So this was a blackout practice exercise, a pretty major project in Germany, the largest to date, you mentioned. Do you know whether these types of practice exercises are occurring at utilities around the world?
Yeah, good question. Actually, I don't have the real insight, but for sure, all around the world, the grid operators, at least the transmission system operators, will have similar concepts. And they also will practice it similar to what the German grid operators are doing. Of course, I mean, it's also possible to practice it in a system simulator. There are specific simulators to train employees and to simulate blackout events. And this will be done probably everywhere. I don't know in which extent exactly, but all the other countries will do this as well. I don't know how often they really do it in practice. I mean, we have also these projects here in Austria, but I'm not aware of any other customers of us doing it in practice right now.
Okay, but it is certainly a hot topic for utilities worldwide.
That's for sure unquestionable, and the awareness all over the world is increasing, definitely.
Very good. Well, Lukas, thank you for joining me for this episode of Energy Talks.
Yeah, again, thank you for having me, Scott. And for me, it was really a nice first-time experience doing a podcast.
Well, we certainly enjoyed having you, and we hope that you will join us again for another topic.
For sure, Scott.
Very good. It was a pleasure to speak with you. Thank you. And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity in the power industry, and offers you the matching solution for your application. For more information, be sure to visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.